Hi everybody, so today we're going to talk about solving inequalities. The big thing with inequalities is you have to graph them, you have to write them in interval notation after you solve them. So we're going to talk about that we've done a little bit of interval notation before, but just kind of a nice review. So if you remember on interval notation, if I have greater than or less than, that's an open circle. All right, so I would use a print C. If it's greater than less than, it's an open circle. I use the print C on interval notation. If it's greater than or equal to, less than or equal to, I use a closed circle, and that's a bracket on interval notation. Right, so what you're going to see is problems like the ones that are below. Some are a little bit different because they throw in some rational expressions in there, but we know how to handle this. So this first one, it says 7z plus 7.2 over 8 is greater than 6z plus 5.8 over 7. Well, what can I do here? I need to get the denominators the same. So I'm going to multiply this first fraction, everything by 7, this one, everything by 8. Well, by now, hopefully you remember that that's going to make the bottoms cancel. So I'm just going to write at the top. So 7 times 7z would be 49z. Plus 7 times 7.2 ends up being 50.4 is greater than 6z times 8 would be 48z. Plus 5.8 times 8 is 46.4. Alright, so now you just go back to traditionally solving an inequality. You want to get your z's on one side and your numbers on the other side of the inequality. So I'm going to subtract 48z. We have z plus 50.4 is greater than 46.4. And the last step would be subtract 50.4. So I get z greater than negative 4. Right, now here's how this works. On the Hawks, they want that answer, but they also want you to write an interval notation and then graph it. So you have to make sure you read the problem. If it says interval notation, what I would do is I would always graph it first on my piece of paper that I was doing the problems on. So z greater than negative 4, well, I'm going to use an open circle because it says greater than. And greater than means I'm going to shade to the right. Now, interval notation, you got to find your starting point. So as far left as I go, in this case, it's going to be negative 4. I'm going to use a parenthesis, comma. I'm going all the way to infinity because that line's going to go on forever. So that's interval notation. That's also what they're after. So every problem is going to have you solve it, write interval notation, and then graph it. All right? So B, I want you to try by yourself. It's a little bit easier, but you should be able to solve it, graph it, and write it in interval notation. So go ahead and pause the video right now, try it, and then I'll talk about it. So what you're going to do, hopefully this is the way I did it. You can do it a different way, but you should still get the same answer. I'm going to subtract my 2z and add my 28.8. So I'm going to get 4z less than, type this into my calculator, 19.2. And then you divide by 4. You get z less than 4.8. So again, you're going to draw your number line, put 4.8. This one's less than though, so it's going to be an open circle. And I'm going to shade to the left. Open circle, I would shade to the left. So now again, you have to write interval notation. So how far left does it go? Well, that would be negative infinity. Right? If you're going to use negative infinity, it always goes first. It's never going to go last. And how far right would be 4.8, and I'm going to use a parenthesis on that. And in negative infinity and infinity, if you remember, it's always a parenthesis. Okay? Keep going. Got 3 more problems. This one right here, very close to all being the same, but I just need to multiply this one by 2 to make the denominator 4. So I'm going to have 18 less than 2y plus 18 less than 22. So now there's 2 inequality signs, so this is how this works. Whatever you do to get the y by itself in the middle, you have to do to both sides of the inequality. So I'm going to get 0 less than 2y less than 4. Last step, we need to divide by 2. So I get 0 less than y less than 2. Now this one, if the y is in the middle, right, you would shade in between. So I don't know if you guys remember that, but if the y is in the middle, I shade in between. I'm going to use an open circle because they're both less thans. Interval notation is how far left? Well, that would be 0. To how far right? That would be 2. That's my answer. All right, go ahead and try D. Very similar problem, right? So now I don't have to worry about the denominator. I can just solve it. So go ahead and try that one by yourself. Pause the video. So subtract 3. Negative 2 is less than 2x, which is less than or equal to 6. I'm going to divide by 2. Negative 1 is less than x, which is less than or equal to 3. Again, the x is in the middle, so I'm going to shade in the middle. Just got to make sure I use an open and then a closed circle, right? Because it's less than, or equal to. So when you write an interval notation, it's 0 with a parenthesis, or not 0. Negative 1 with a parenthesis, all the way to 3 with a bracket. Go ahead, pause the video, try E. I think you can do that one by yourself as well. Right, if you're doing E and you move the 5t over and then you add the 6, you get negative 2t greater than or equal to 8. Now don't forget, when you divide by negative, what happens to your inequality sign? So if I divide by negative, or even multiply, most of the time we end up dividing though, but divide or multiply by negative, it flips the inequality sign. All right, so here it's going to be 2 less than or equal to negative 4. So I'd graph negative 4, put a closed circle. I'm going to shade to the left because I want less than or equal to. All right, and then it should be negative infinity with a parenthesis all the way to negative 4. With a bracket. And that would be your answer in interval notation. So that's what you're going to see on the Hawks, is if you have an inequality like that, it's a nice review of how to write an interval notation. But then we also get into absolute value problems. So absolute value inequalities, all right, same thing, we're going to write an interval notation and graph it. But you have to be careful, so whenever you get the absolute value by itself, you have to decide whether it's an and or an or statement. All right, so if it's less than, it's going to be an and. If it's greater than, it's going to be an or. So this first one is an and statement. Second one's an or statement. It does not matter if it's less than or equal to or greater than or equal to. You just look at which way it's going. So if it's less than or equal to, that's an and. If it's greater than or equal to, that's an or. All right, so now you write your two equations like we did with absolute value problems. Okay, I would get two answers. So I want it to be greater than negative 6 and less than 6. Well, most of the time, ands, right, you're going to shade in between. So when I write an interval notation, negative 6 to 6. Now an or statement is going to look like this. I have x greater than or equal to 4. You write your two equations. You don't really have to solve anything, right? Normally we would solve after we got the absolute value by itself, and we'll do some examples of that later on. But I get this. I'm going to graph it. Now here's the thing. They're both closed circles, right? But I want less than or equal to negative 4, so I'm going to shade to the left. Greater than or equal to positive 4, so I'm going to shade to the right. So most of the time, or has a gap. So when you write this in interval notation, you have to say negative infinity to negative 4 with a bracket, union 4 to infinity. And I know we did examples like this, but it was at the beginning of the year, so just trying to piece it all together now. That's how you would write that interval notation. All right. So now at the bottom, they get a little bit harder. So you're going to solve each absolute value inequality, write the solution as an interval notation, and graph it. So the first one, you want to get the absolute value by itself. It is by itself, so I can go ahead and say it's an and or an or statement. This one's going to be a and statement, and so then you would write your two equations. Don't forget you change the sign and flip the inequality of the number that's not inside the absolute value, and you flip the inequality sign. So I'd add the 5 on both of them. Go ahead and solve it. So x is less than or equal to 7, and x is greater than or equal to 3. If I were to graph that, put closed circles, and means you shade in between. So it'd be 3, 2, 7 with brackets. All right. Next one, a little bit harder because you have to divide or subtract 3, but then I have this. And people kind of forget that that negative out there means -1, and that's what I'm multiplying by. So to get rid of it, I'm going to divide by -1. It's going to flip your inequality sign and change it to a +6. Remember when you multiply or divide by a negative, it flips it. All right. And then from there, what you have to do is decide whether it's an and or an or statement. Well, this one's going to be an and statement again. Wrote my two equations, now I'm going to solve them. X is greater than -1 because I divided by a negative. X is less than 5. So -1 to 5. Put an open circle on both of them. Shade in between. It works. All right, so that's pretty much the gist of it. I want you to go ahead and pause the video and try C. Right, so your first thing is to get the absolute value by itself and try and solve it. So on C, hopefully the first thing you did was divide by 5. And then you're going to say, hey, it's an and statement. So I'm going to write my two equations. Subtract 5, subtract 5. So it's greater than -7, but less than -3. So -7 is going to come first on our number line, right? Open circles. And that's how you write it in interval notation. Okay? Bottom one, they're going to tell you whether it's an and or statement, but these get a little bit tricky. So you have to be careful when you're doing these. So let's go ahead and solve the problems individually. So I'm going to solve this first problem. I'm going to go ahead and solve it. All right, so the first thing I want to do is I think I'm going to distribute this negative. You could have divided by -2, but I'm going to distribute it. Subtract my 2. And then divide by -2. But don't forget when you divide by a negative, right, it flips the inequality sign. So now I have y greater than or equal to -7. I'm going to say and, subtract 12. Now we're going to solve this inequality, divide by -1. Y is greater than -2. All right, so that's my and statement. But when I graph this one, be careful because they're both greater thans, right? Well, here's what happens. In an and statement, you only take where they overlap. I know we talked about this at the beginning of the year, but it's a nice review. So -7 to -2 does not work because that only works for one of the lines. But -2 to infinity works for both lines, and that's why it says and, because it has to be both. All right, so in B, it's the same problems. I'm not going to solve them again. So you're going to get y greater than or equal to -7 or y less than -2. But on this one, when you graph it, same thing. Okay, graph looks the same. But it's an or statement. So or just has to work for one of the lines. So -7 to -2 does work. So I would say the answer is -7 to infinity. So you have to make sure you answer what it's asking. If it's an and statement, it has to be the overlap. If it's an or statement, it just has to work for one of the lines, this or this. Right? That is 3.4, solving inequalities. If you guys have any questions, please let me know. Send me an email, reach out. Your homework is going to be paper homework. Make sure you get that done.